Welcome back. We are continuing with how to standardize data. In the last video, you were introduced to the z-score and we're shown how to convert individual values into a z-score. You also got a taste for using the central limit theorem in order to convert an x bar into a z-score. And we're going to focus on using the standard normal distribution table today. And that's what you have on the screen in front of you. So this is also available on Canvas. If you go under modules and tables, you should be able to find the Z table. And this is what you should see. So let me talk you through what this table is showing you for a moment before we actually make use of it. Any good table should have a figure or a diagram of the underlying distribution like this one does here. And it looks like it is bell-shaped. It's symmetric, so it's normal. It is centered about 0. Well, the 0, I don't think by default is in the table, but being that it's standard normal, I know 0 is in the middle. And it also tells you that z-scores are on the bottom and that the probabilities in this table are areas to the left of that z-score. So this table gives probabilities, which are areas, underneath the table. And it only gives it to the left of the desired z-score. All right, so how do you make use of this? Well, in all the problems that I did in the past video, you may or may not have noticed that I always wrote the z-scores with 2 decimal places. And the reason is that the standard normal table uses 2 decimal places. If you look at the first column there, you see z-scores. It's labeled Z on the top here. But you have z-scores with only 1 decimal place. So you might ask, well, where's the second decimal place? And that is here. So there's your second decimal place, and here is the first. So how do you make use of this? Well, if the z-scores are that first row and first column, then the body of this table must be your probabilities. So those 4 decimal place numbers are probabilities or areas under the curve. And remember, they're always to the left, according to this picture. So let's show how to make use of this. I've got a bunch of examples and practice problems on the right side here. And the first one is we want the probability that z is less than negative 2.78. So it's a less than probability. It is a negative z-score, and I want the probability or area to the left. And so I'm going to go here and I'm going to look for negative 2.7. And so I'm going to be looking in this row here. And 8 is my second decimal place. So I'm going to look in this column. And the intersection is the answer. So 0.0027 is the probability or the area to the left. It's a pretty small probability, which seems to make sense. And so I do have a picture here, 0.0027, perfect. The picture I've got right here on the left, negative 2.78 is pretty far over, and the area to the left of that is small, negligible, certainly less than 50%. And what we get is it's more like 0.27% or 0.0027. Let's take a look at the next one. Probability that z is less than or equal to negative 3.00. This is less than sign, or the equal sign doesn't actually impact the answer. And it's negative 3. So I'm looking for negative 3. And I see negative 3.0 here. The 0, column is that first one. And so I've got the answer of 0.0013. 0.0013. So let's go ahead and make sure. Bingo. So now take a moment to see if you could get it for the probability that z is less than or equal to negative 1.11. That's the third one here. So I'll give a few seconds for you to tackle that. All right, so hopefully you were able to find it. Again, you're looking for negative 1.11. So you're finding negative 1.1, that row, and then 0.01 to account for 1 in the second decimal place. And the intersection is at 0.1335. So hopefully that is the answer that we got. And there it is, 0.1335. Excellent. All right, so that is the area to the left of a negative z-score. But what if you want to the right of a positive one? And so here we want the probability that z is greater than or equal to 2.78. So in that case, we have a picture that looks more like this, and 2.78 is here. Now earlier we had negative 2.78, and we had found this area. Remember that this is standard normal, so it's centered about 0 and symmetric. So how should these two areas compare? Hopefully you saw pretty quickly that they should be the same, which means that the area to the left of negative 2.78, we got that to be 0.0027 earlier. So that should be the same answer that we got here by symmetry. And you do the same idea for the other two. So pause the video, try to find the answer for the area to the right of 2 and the area to the right of 0.65. And then when you're ready, start the video back up again. Let's see how you did. So hopefully you got 0.0228 for the area to the right of 2. So that's going to be the same as the area to the left of negative 2. When you look at negative 2.00, you should get 0.0228. And likewise, if you go to 0.65 and look at negative 0.65, so here's negative 0.60, 1, 2, 3, 4, 5. You should get about 0.2578, which is what I got, and hopefully you got that too. All right, so far so good. So we've done the area to the left of negative, area to the right of a positive z-score. What about area to the right of a negative z-score? Well, you were introduced to the complement rule in a previous video, and that's what we're going to make use of here. So the area to the right of a negative z-score is just going to be 1 minus area to the left. Because for this to be a valid distribution, the sum or the total probability, total area under the curve, must be 1. And you learned how to get the area to the left just a moment ago. So now we want the probability that z is greater than negative 0.5. Greater than negative 0.5. Well, less than negative 0.5 would be 0.3085. So this region right here is 0.3085. But what we're interested in is this region here. So if you do 1 minus 0.3085, you will get 0.6915. Let's take a look at one more. The area to the right of negative 1.36. So negative 1.36. This is 3, 0, 1, 2, 3. Okay, that's going to be this value here. But that's the area to the left. We want the area to the right. So you subtract that from 1, and you've got 0.9131. That's go ahead and see that. 0.9131 right there. Again, pause the video, try to find the next two answers. The probability that z is greater than negative 2.21 and greater than or equal to negative 3.00. And while you're at it, it's a small leap, in my opinion, to find the areas to the left of positive z-scores. So that's going to be step 4 there. And so see if you're able to get those also. And when you're ready, hit play. Let's see how you fared. All right, so what you should have gotten for the first two are 0.9864 and 0.9987. So you want, again, the areas to the right. Most common mistakes here are not knowing whether you should or should not subtract from 1. Again, I think pictures are really, really helpful. So just to demonstrate again, if we wanted to visualize this problem here, we want the area to the right of negative 2.21, which means we want this region. So if you were to look up in the table and you see 0.0136, you should ask yourself, does this area look like just 1.36%? And you should say no very quickly. It looks like it's most of the area under the curve. So there's no way it's only 1.36%. It's got to be the other part. So you subtract that from 1 to get at it. I really strongly encourage you to draw sketches like this in order to try to ensure that you're on the right track. It doesn't help with looking up values, but it does help to decide whether to subtract from 1 or not. All right, what about part 4? So this is one that you could have figured out on your own. The area to the left of 2, well, you know that the area to the right of 2 is the same as the area to the left of negative 2. We did that earlier. And so by symmetry, the area to the left of 2 must be the same as the area to the right of negative 2. So that's one way that you could have gone about to solve this. So you could get 1 minus the area to the right of 2, but the area to the right of 2 is the same as the area to the left of negative 2. And that comes directly from the table 0.0228, which when you subtract from 1, you get 0.9772. Now, again, that's also the same as the area to the right of negative 2. For the next one, the area to the left of 2.3, you could get 0.9983. And I'll give you the other answers so that you could check yourself. And that's what you should have gotten or should be able to get. And so if you didn't get them, take a moment to look this over, record it, take a picture, pause the video. Try to understand how I got those values. All of these previous steps can be used to do the last case that you might encounter, which is the area between two z-scores. And so in the first one, the probability that z is between plus and minus 1. So there's a few ways that you could do this. And the first is that you might take a picture like this. And we want the area between plus and minus 1. So we're interested in this region here. But using their table, you know that this is going to be 0.1587. And by symmetry, this is also 0.1587. So one approach that students often like is to get the tails, add them together, subtract those from 1 in order to get the middle part. And that's what I've done here. And you will get 0.6826. Now, another approach that works is to view it more like what I've written in part 2 here. and that is to get the area completely to the left of 1, but that area has a little too much. Whoops, sorry. That area has a bit much. It has this yellow region here that we want to subtract off, and that region is 0.1587. So if you remove that from the total area less than 1, you're going to get 0.6826. And so you can convert the area between to the difference between two areas. So that would be the area to the left of the larger z-score, and then subtract out the area to the left of the smaller z-score. I tend to do that second way more, but I find a lot of students understand the first well. Either's fine, they both work, they both make sense. All right, so here are a few more problems for you to practice. Let's go through one more together. So we want the area between negative 0.75 and positive 1.57. Based on my shading, I got the area to the left of 1.57, and then I subtracted from that the area to the left of negative 0.75. So the area to the left, let's do this together, area to the left of 1.57. So 1.57, that is going to be, if we look up negative 1.57, you will see 0.0582. But that is 0.0582. That's going to correspond to this small piece here, 0.0582, which means that the yellow region is going to be 1 minus that, or 0.9418. And that's the total yellow region, including the green part that's put on top of some of the yellow region. The green region is the area to the left of negative 0.75. And so negative 0.75, you should get 0.2266. 0.2266. So this piece here is 0.2266. And if you subtract those, you should get the right answer. And so here is my work for that. So 0.9418 minus 0.2266, and you get 0.7152. So about 71.5% is the probability. Pause the video here, try to find the answer to the last 4, and start the video when you're ready. Okay, so screen probably magically shows the answers at this point, and that's fine. Hopefully you attempt it yourself to see how well you understand and what you're able to figure out or can't. For this first one, the probability that z is between negative 3.34 and negative 2.08, I did the subtraction approach. So I got the area to the left of negative 2.08 to be 0.0188, and the area to the left of negative 3.34 is 0.0004. And when you subtract those, you get 0.0184. For the next one, the area between two positive z-squares, I did subtraction again, but here by symmetry, I know that area is going to be the same as the area between the negative values. And when you negate, you also flip them. So while 1.99 was the larger positive value, negative 1.99 is the larger negative value. So it should be on the left side. And then just like I did in the first one up on top, I did a subtraction of the corresponding probabilities and got 42.1%. The last two are good ones to have gone through, and I'll explain why in a moment. You should get the area between plus or minus 2 to be 0.9544, and the area between plus or minus 3 to be 0.9974. In this case, I did, I got the two areas in each tail, added them up, and subtracted from 1. So that 2 times is because the area in each tail is the same value. So that's the approach I used here, but either approach would work. And the reason that I had you go through this is because last class, believe it was the last one, you had learned about the empirical rule, which says that 68%, the number highlighted in blue, 0.6826, 68% are within 1 standard deviation of the mean. And for standard normal, that is 0 plus or minus 1 times 1. 95% is within 2 standard deviations, and 99.7% is within 3. So that's the empirical rule, which is an approximation, and you just solved the exact probability for all 3 cases. So 0.9974, 0.9544, and 0.6826. And so you can see how similar they are. It is pretty close. So it is a good rule to be familiar with. But the last thing I want to end on is I want to return way back to problem 4, I believe it was, in the last video. And we had converted the 2 z-scores into probability statements or p statements, but we didn't actually finish these. And so now you have the skills to be able to do so. And if you find the area or the probability in part A, you should get 0.3272. And you can pause the video to check before I show you in just a moment, but you could do the same thing or same idea for part B, and you should find that that probability is very small, and that's 0.0029. So it is good to have gone through both of those routes. And here's just a nice picture to show that it'll be pretty small. And that's it for standard normal data. So where we're moving into next, that's all for descriptive statistics. The rest of the course is going to be on inferential statistics, and that's where we're moving into next. Take care.